Hello friends, Standard 12 Chemistry Unit 10 Haloalkanes and Haloarenes Part 6. In fifth part we learn method of preparation of haloalkanes. In this part we learn physical properties of haloalkanes and haloarenes. Here we discuss three physical properties. Number 1, melting point and boiling point. Number 2, their density, and number 3, their solubility. Most of the alkyl halides are colorless, but when it is exposed to light, chlorides or bromides develops color. And next, that is volatile halogen compound are in sweet smell. Number 1, melting point and boiling point. Molecules of organic halogen compound, they are in polar nature, and due to greater polarability, intermolecular force of attraction, here like dipole or van der Waals force, a stronger in halogen derivative, and that's why boiling point of chloride, bromide, iodide are considerably higher than hydrocarbon of molar mass. Here the decreasing order of alkyl halide for boiling point, alkyl iodide is greater than alkyl bromide is greater than alkyl chloride is greater than alkyl fluoride. Here the atomic number of fluorine is 9 for 17, bromide for 35, and here iodide for 53. That means here alkyl iodide has highest boiling point and alkyl fluoride has lowest boiling point. Next point for boiling point is decreases with increase in branching like iso and neo. Here the examples CH3 CH2 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 Br. 1 2 3 4. Here 4 carbons, and first carbon bromine group is present, so 1 bromo, butane, and its boiling point is 375 Kelvin. Number 2, CH3 CH2 CH CH3 Br. Here number 1 2 3 4, 2 bromo, butane, and its boiling point is 364 Kelvin. Number 3, CH3 CH. Here we add 2 branch CH3 Br. Number 1 2 and 3, 2 bromo, 2 methyl propane, and its boiling point is 346 Kelvin. So here the example, here it is straight chain or longest chain, and their boiling point is 375. Here we have only one branch, it is called iso, and their boiling point is 364. Compared to it is decreased because of the increase in branch. And in third example, here boiling point is 346. Here we say 2 branch, and it is called neo. So that's why boiling point is decreased with increase in branch. And you can see here, this is all are isomers, position isomer. And next point, for most of the para isomer, is greater than ortho and para isomers of melting point. And so most of the para isomers has higher melting point as compared to ortho and para isomers. Now second physical property, that is density, is increases with number of carbon atom. That means here the number of, as the number of carbon atom is increases, for example here CH3 CH2 Br, CH3 CH2 CH2 Br. Here the number of carbon atoms are number 1 and number 2. Here 1 2 3 means what? Here number of carbon atoms is increases, the density is increases. Number 2, number of halogen atom is increases. And number 3, as atomic mass is increases, the density is increases. Here the 3 factors is affected on density of haloalkanes Number 1, on increasing number of carbon atom, on increasing number of halogen atom, and on increasing atomic mass. And number 3, physical properties, their solubility. The solubility is low in water molecule. Okay friends, so here you have to remember this series for decreasing order of alkyl halide. This is very most important for MCQ. Okay, now our next topic, it is very most important, chemical reaction of haloalkanes and chemical reaction of haloarenes. First of all, let's see here the chemical reaction of haloalkanes. Number 1, nucleophilic substitution reaction. It is also number 1 here, SN1, number 2 SN2, and stereo aspect of nucleophilic substitution. Number 1, optical activity. Number 2, chirality. Number 3, retention. And number 4, inversion. For optical activity, here we discuss dextro-rotatory and levo-rotatory. Is number 1. Number 2, elimination reaction. And number 3, reaction with metal. Reaction with metal, Grignard reaction. And number 2, Wurtz reaction. So this is the main chemical reaction of haloalkanes. Number 2, number 1, nucleophilic substitution, again classified into SN1 reaction, SN2 reaction, and stereo aspects of nucleophilic substitution. They are also included in SN1 and SN2 reaction. Optical activity, here we discuss dextro-rotatory and levo-rotatory. Number 2, chirality. 3, retention and inversion. For elimination reaction, here we discuss chef rule. And number 3, reaction with metal. These two reaction is number one, nucleophilic substitution and reaction with metal is also included in chemical reaction of haloarenes. So here chemical reaction of haloarenes. Number one, nucleophilic. Number two, electrophilic substitution. Here substitution. And number three, reaction with metal. Here two reactions is very most important. Number one, Wurtz-fittig reaction, and number two, fatigue reaction. So here first of all we discuss a reaction with metal of haloalkanes and haloarenes combinedly of reaction with metal. Here sodium metal or magnesium metal. Number one, Grignard reaction. Alkyl halide and reaction with magnesium in presence of dry ether to yield alkyl magnesium halide. It is called alkyl magnesium halide. So this magnesium is electropositive and this would be electronegative. So this is called alkyl magnesium halide. It is called Grignard reagent. This Grignard reagent is readily decomposes, that's why it is stored in ether medium. This Grignard reagent and react with any protonated reactant. Here is partially positively charged and Z is partially negatively charged. That gives alkane and magnesium halide. And here suppose we take water molecule, alkane and magnesium hydroxide. Let's see example for Grignard reaction. CH3 CH2 Br. It is called ethyl bromide on reaction with magnesium metal in presence of dry ether. We get CH3 CH2, magnesium is added and we get Grignard reagent, which one further react with water molecule, here H plus and OH minus. One hydrogen is added to this carbon, we get CH3 CH3. It is called ethane. This will be our alkane, and another product will be formed. This hydroxide is added to MgBr, MgOH Br. This is the first example. Number 2, reaction with, suppose here methyl iodide on react with magnesium in presence of dry ether. Simple, magnesium is added, CH3 Mgi. This is called methyl magnesium iodide, or this is our Grignard reagent. It's called also ethyl magnesium bromide. Okay, or you can write directly Grignard reagent. Further react with water molecule H plus and OH minus. This H plus is added to methyl, we get methane, and this hydroxyl is added to magnesium iodide, MgOHI. Methane. So here in this reaction we take 2 carbon of halide, and after that reaction we get 2 carbon of alkanes. Okay, 2 carbon of halide and same number of carbon, let's get, okay, same number of carbon here. Suppose you are taking 3 number of alkyl halide, you get 3 number of carbon of alkanes. Let's see another reaction. Suppose alkyl halide on reaction with sodium metal in presence of dry ether to yield alkane and sodium halide. Here are 2 moles of, here we get 2 alkyl group, you need to balance twice and twice. For example, here we take CH3Cl plus sodium metal plus another molecule CH3Cl, same molecule. It's called methyl chloride, methyl chloride in presence of dry ether. This chlorine is attached with sodium metal, and these two methyl is attached with each other, CH3. It is called ethane plus another product that will be NaCl. Here we get two methyl groups, so we have to balance twice and twice NaCl. So from this equation reaction we get double number of alkane. Here we take only one alkyl halide, one carbon of alkyl halide, and we get two carbon of ethane or alkane. So in short, by Wurtz reaction, double number of carbon is produced or formed. So complete here. Suppose alkyl halide on reacts with magnesium metal in presence of dry ether, Grignard reaction is carried out. Suppose alkyl halide on reaction with sodium metal in presence of dry ether, Wurtz reaction is carried out. In Wurtz reaction, main thing is double number of carbon is formed. Let's see example. Suppose here 2 moles of CH3 CH2 Cl. It is called ethyl chloride on react with sodium metal in presence of dry ether. Now this chlorine is attached with sodium metal and we get CH3 CH2, again CH2 and CH3. It is called normal butane plus 2 moles of sodium chloride. So from this equation, here we take 2 carbon and we get 4 carbon, means double number of carbon is produced. Another example, number 3, this will be number 2, CH3 CH CH3 CH2 Cl, 2 moles. Okay, number 1, 2 and 3 is called 1 chloro 2 methyl 1 2 3 propane on react with sodium metal in presence of dry ether. Simple. Repeat this molecule 2 times. Dry ether, and this will be react with, so here twice NaCl, CH3 CH, CH3 CH2, and again repeat this molecule, CH2 CH, CH3 CH3. So here we have only 3 carbon. This is the longest chain, and you can number 2, number 3, 4, 5 and 6. On 2 second position and 5th position 2 methyl group, 2 5 dimethyl, 1 2 3 4 5 6 hexane. So complete. Here the main branch is here only 3 carbon. We get here the series of 6 carbon. So from 3 carbon to 6 carbon, and double carbon is produced. Number 4, CH3 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 Cl, 1 2 3, 2 chloro, 2 methyl propane, and react with sodium in presence of dry ether. Now here let's see the arrangement. Number 1, CH3 C, CH3 Cl and CH3. So from this equation, this will be our longest chain. From this equation, CH3 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 CH2 CH2 C, CH3 CH3 and CH3 will be formed. And here this chlorine is sterical hinders by 3 methyl group. Now let's see free radical or ionic mechanism for Wurtz reaction. 2 moles of methyl chloride and react with 2 moles of sodium in presence of dry ether. We get CH3 CH2 CH2 CH3. Here from ethyl chlorine will be removed and we get ethyl free radical. On heterogeneity of ethyl free radical, one carbon will be here oxidize, and another will be reduced, and we get two products, ethene and ethane. Here some limitations. Odd number hydrocarbons cannot be prepared in pure form like methane, propane, C5H12, methane, propane, pentane, heptane. Is not possible by Wurtz reaction. Now reaction with metal for haloarenes, as we discussed earlier. Number one, Wurtz-fittig reaction and fittig reaction. Number one, Wurtz-fittig reaction. As we discussed, first of all, Wurtz reaction is carried out in presence of dry ether and sodium metal. Same thing is here, but the main difference is here we used here aryl halide and alkyl halide. This is the main difference between simple Wurtz reaction and Wurtz-fittig reaction. In Wurtz reaction, we take alkyl halide and sodium in presence of dry ether. In Wurtz-fittig reaction, we used aryl halide and alkyl halide. This is the main difference, and product will be formed aromatic hydrocarbon, dry ether. Two moles of, for example, Wurtz-fittig is aryl halide, chloro, benzene, and react with sodium metal and methyl chloride in presence of dry ether. This chlorine, we get this methyl group is attached with benzene ring. Product will be formed. It is called toluene or methyl benzene. So from this equation, double number of carbon is not prepared also. Now fatigue reaction. Here only aromatic halide or aryl halide is react with sodium metal in presence of dry ether. Two aromatic ring is joined together, means here it is called biphenyl. For example, suppose chlorobenzene on react with sodium metal, another chlorobenzene, 2 moles of chlorobenzene, and this reaction is carried out in dry ether. These two biphenyl ring is directly attached. It's called biphenyl. So insert reaction with metal. Suppose here Grignard reaction, number 2 Wurtz reaction, Wurtz-fittig reaction, and number 4 fatigue reaction. Grignard reaction is carried out with magnesium in presence of dry ether. So in all this reaction, medium is common, dry ether. Here for Wurtz reaction is carried out with sodium metal. Wurtz-fittig reaction, here alkyl halide, also alkyl halide on react with sodium metal, alkyl halide with magnesium. Wurtz-fittig reaction, aryl halide plus alkyl halide in presence of sodium. In fittig reaction, only aryl halide react with sodium metal. So this is the main part of this reaction with metal. These two reaction is for haloalkanes, and these two reaction is for haloarenes. Okay friends, so next time we will discuss nucleophilic reaction, SN1 and SN2 mechanism. Thank you very much.